Hello everyone. We will talk today about data wrangling. I will walk you through preparing school data project exercise. It's lesson number 5 in data wrangling section. Before we start with the practice, I want to tell you that I will change a little bit in the solution. You you might find my workflow a bit different from the one in the learning materials. I'm just trying to show you more than one way to do the job here. So let's get started. Uh, let's see the business issue or the business problem here. We have a school district wants to predict the cost per pupil of a school based on some high-level summary data about the schools. We have to prepare the data for modeling. Our first step is data understanding. We have 4 CSV files that contain data for 2 different school districts. I've already downloaded the data. Okay, so we have 4 files, 2 of them for each district. We have attendance, which contains school average daily attendance, percent attendance, pupil teacher ratio, and we have finance dataset which contains school value and metric. We have 2 metric, per pupil cost and average monthly teacher salary. So that's about the data. The next step is to prepare data. The first step in data preparation is to combine the data. But before we start combining our data, let's check the data type for our dataset. We can use select as usual to change the data type manually, or we can select autofill tool. This tool will check the data type and change it automatically to the best fit data type. So let's check it out. I'm gonna add 4 uh, autofill tools, and I'm gonna check the result by using select tool. Let me run it. Okay, school string average double. No, it worked. So now to combine the data, remember this rule, uh, 1 row per school. This is the basic to our work. We are trying to build a model to predict the cost per school. So it makes sense to build our dataset on school level. Let's go back to Alteryx. Okay, attendance table. Uh, it seems ready to use and no need to modify it. We have 1 school uh, for each row. So we have the data set on school level. But what about finance? Here we have 2 rows for each school. So we need to modify the format of this dataset. We can do it by using crosstab to turn rows into columns. Remember, we need to create 2 columns for the metric field here. So I'm gonna use it like this. For rows, I'm gonna keep school. For columns, I'm gonna choose metric, and for values, I'm gonna choose value. Sum or average here, it's gonna get the same result. So I'm gonna add another one. school metric and value. Okay, now we have one school in each row, or one row for each school, sorry. So now let's make one file for each district. We can do that by using join. uh, Join tool. I'm gonna use school here. Then I'm gonna take out one of the school fields here. I have two fields for school. I'm gonna take out one of them. Also, I'm gonna take out the blank fields. Let me add another one for this district B. So join school. Now I have one file for each district with all the information about this district. So now I need to have one file contain all the data for both districts. So let me use uh, union tool. Let me run it now. Now we have one file contain all the data from the four files here. Now let's move to our next step. Clean the data. We need to clean the data, which include duplicate data and missing data. But before doing that, let me rename the fields here, because honestly it's very long names and kind of funny names. So let me use select. Okay, average, let's say D, and AMTS. Oh my god. And for the target variable BBC. Okay, now let's deal with duplicate. I'm gonna use unique tool on school level. So let me see, what do we have here. We have one duplicate record for this school. Let me check the data for this school. Okay, oh, here it is. Actually, we have the same values in both records, so we don't need to worry here. We just need to take out one of the records. We're good. Okay, what about the missing data? Simply, I'm gonna use filter tool to take out or to delete all the records with the missing values. But before that, I'm gonna check the outliers. Uh, I'm gonna save our result here. So we don't have to run the whole workflow every time. Let me save it by adding output data tool. I'm gonna use this one. Okay. Let me run it again. Okay. Okay, here we have our dataset, combined dataset without duplicate. So, outliers. We can use Excel, as you learned in this course, to calculate the lower and upper fence. But I want to show you how you can do it in Alteryx. We will calculate the upper and lower fence and identify the outliers here. This is the data. Okay. First, let me do a little trick here. I'm gonna use select tool to rename one of the fields. We're gonna start checking on the ADT field. So I'm gonna rename this field to 1. Now, first, we're gonna start calculating the first and third quartile. We can do that by using summarize tool. Okay. I can use numeric percentile. For the first quartile, I need to put 25% here. And for the third, I need to make it 75%. Let me change the name. First quartile and third quartile. Now we have to calculate the interquartile range. We can use formula tool. Add a new column. Interquartile, which equal to the third quartile minus the first. Now we have our range. Okay. Always remember to choose the correct data type for your field. It's numeric, so I'm gonna choose double. Then I'm gonna calculate the upper and the lower fence. Okay, I'm gonna add new column here. Lower fence, which equal to first quartile minus interquartile range times 1.5. Remember this formula. And we need to make it double again. Upper quartile, upper fence, sorry. Third quartile plus interquartile range times 1.5 and double. Let's run it again. Now we have our data. We have the lower fence value and the upper fence value. I need to add these values to our data set in order to compare it to the variable values. So I'm gonna use join group append. Okay. Let me do it like this. And now let me run it. So we add the new data to our data set. Now, to find out the outliers, I'm gonna use filter tool. So the outliers value should be more than, okay, let me choose the field first, which is 1, should be more than or higher than the upper fence, or lower than the lower fence. See, we have three values as outliers. We have 4K, 3K, and 1K in the uh, average daily attendance. So, to check these outliers and to check the relationship between this variable and the target variable, we can add scatter plot here. Okay, to the data. I'm gonna choose the BBC, which is the target variable, and one. And I'm gonna add browse tool. Let me uncheck the smooth line and let me run it again. Now remember, I have three outliers value here, 4K, 3K, and 1K. Okay, this is the 4 and 3K values. I think it's wrong data entry. It's very weird values and very abnormal values. And I think we can divide it by 10 because we can see that the average values in this field is between like 5, 6, 700 or 400. So if we divide it by 10, we're gonna get 300 something, 400 something. It looks reasonable. But what about this value, 1K, 1K something? It seems like this data is accurate and it's just a larger or bigger school here. So my concern with keeping this observation is that it may skew the data and it could affect the relationship with the target variable. Uh, what I'm gonna do here, I'm gonna build two models. One include this variable and one exclude this variable. So we're done. One include this value, sorry, and one exclude this value or outlier. So we're done with this variable. Now, here it comes my little trick. Remember, all the steps I did in this workflow, I did it on a field name 1. So if I want to get the same data for the next field or next variable, I can simply delete 1 from here and rename this field, the BT field, to 1 and run my model again. And I'm gonna get the outliers value for the BTL field. Pretty nice, huh? Okay, let me check. No outliers here. Great. Okay, let's check the next variable, BTR. So we have two values, uh, 23, 22.6. Let us check the relationship. Okay, this is our two outliers, but they are also outliers for the BBC for the target variable. See, they are outliers. So it makes sense actually. We would expect the relationship to be like this based on the line, the fitted line. So I think we don't have to do anything about these two outliers. Let us check the next and the final variable. Okay, we have also two outliers, 106, 106. Okay, let me check the relationship. Okay, those two outliers. I think this case is it's just like the previous one with PTR. I don't think there is a huge effect for the outliers on the relationship line or the fitted line here. So I don't think we need to change anything here. We can just keep the values. So let's summarize the outlier situation after we checked all the variables. For the first, let me see, for the first variable ADT, we have three outliers. Uh, we will modify two of them by dividing them by 10. And then for the third outlier, we're gonna create two datasets to create two models, one including the outlier and one without the outlier. For the rest of the outliers, we're gonna keep them. We're not gonna modify or delete any of them because they don't have any effect on the relationship between the variable and the target variable. So let's go back to our original workflow. Remember, we have to deal with the missing value. So I'm gonna use filter tool. I'm gonna select the ADT, which has missing values, is not null. Okay, now remember, for the ADT, I have three outliers. The first two, I need to divide them by 10. So I'm gonna use formula tool. I'm gonna use it on ADT. I'm gonna use if remember we have 3k and 4k for outliers. If ADT more than 3k, then ADT divided by 10 or keep the original value. So I will modify the two outliers. Now we have to create two datasets, one including the third outlier, and one without the outlier. This one include the outlier. Now I'm gonna create one without the outlier. So I'm gonna use filter tool. School doesn't equal to, let me get the record of the third outlier. This one. See, this is the 1k. Okay, not equal. Now I have two clean data set, one with the third outlier and one without the third outlier. See, no missing values. This one with the third outlier, this one without it. So let's build a linear regression model for the both scenarios. So I'm gonna add a linear regression here and linear regression here. So this one, the first one. With outlier. I'm gonna choose all the available variables and add all only to the R output. So for this one, linear regression without outlier. Again, BBC. Okay, now I'm gonna run the model. Remember, uh, I'm just trying two samples or two examples here, one with the outlier and one without the outlier. But in reality, we have to try different combination until we get the best adjusted R square. So let's give it a few seconds here. Okay, this one with the outlier. Okay, let us check the p-values. I think we don't need to use the pt variable. It doesn't has a very good p-value here, so we can exclude it from our model. Okay, what about adjusted R squared? 0.59. Okay, let's see the other one. Exclude the outlier. Okay, the same note for the pt variable. Okay, the adjusted R squared here 0.6. It's slightly better. I think this model is better to use here in this case. Now we're done with our exercise. Next, I'm gonna take your questions, so please prepare it. But first, let me stop our broadcasting.